SageMathCloud.
All right, thank you. So I'm going to tell you about a website that I started about 2 years ago when I was teaching a mathematics class, and I wanted to make it fairly easy for all the students in the course to use Python through a web browser, edit files, create little LATech documents, use IPython, use Sage and Octave and R and all these other programs that I wanted to talk about in the course. So the site I'll show you today, which is, I'll write down the URL. Except I won't, since there's no way to write. So I'll write on the board the URL, in case you can't see it. But the kind of short thing, in case you completely fall asleep in the next 30 seconds, is that this is a website through which you can use R, Sage, LATech, Octave, etc. So if you don't want to have to install anything on your computer, but you want to use R, this is a solution to that problem, etc. So I'll show you how it works. I might need it again. So. Okay, so this is the site. If you just go to the site, this is what you see. And you can create an account right here, or you can read about some of the features over here. And creating an account is pretty standard. You agree to the terms of service, and then you put your name, email, password, and you click the big green button, you get a free account. Or alternatively, you can just click one of these buttons, Google, Facebook, GitHub, or Twitter, and it will use your existing Google, Facebook, etc. account to authenticate you, so you don't have to make up a separate password just for SageMathCloud. Okay? So, not surprisingly, I already have an account, so I will sign in. And it looks like I have my stuff auto-saved. Okay, I'm now signed in. This is my account settings. It's the first thing you see when you log in to SMC. And there's some information that you can put a name in. There's an email address. You don't have to use an email address at all in case you're authenticating via Google, Facebook, etc. This is orange because I've set up a link with Google, so I can also log in using Google. If I were to click, say, on Facebook, I could add an additional link to Facebook, so I could use my Facebook login instead. Currently, it doesn't do anything like post to your Facebook timeline, but it might be possible to do that in the future. There's some other settings which I'll come back to, which make more sense once you've seen how the system works. Okay, so once you create an account and log in, the next thing you do is you click on Projects, and you'll see a list of nothing. This will be completely empty, so it'll look kind of like that. You won't see anything at all because you don't have any projects yet, unless you were invited to SageMathCloud by somebody else, and then you'll see the one project they invited you to. This commonly happens for courses, for example. Okay, so now let's make a new project, which I'll call ACMS. What's the 498? Okay. Demo on April 23rd, 2015. Let's put something here for fun. We're in Condon. Okay, so now I click the Create Project button, and it will create a new project, which will show up right here once it's done being created. It's in this big list of all the projects I'm a collaborator on. And now I will click on the project to open it, which will take, it said 30 seconds, but it's already opened. So here's my new project. So this is the sort of thing you typically see when you use SMC. You can upload files to the project. You can also add other people to the project, and they'll be able to equally use the project, just like you. Edit files, use code, whatever. So let's try first creating a file by clicking Create a File. There's a couple of different types of files. What you'll want to do may depend on what you're doing. So, for example, this says LATech document. Let me zoom in so you can see. please. So some of the most important ones are you can make a Sage worksheet, a Jupyter notebook. Jupyter is the renamed version of IPython, a LATech document, or a terminal. So those are probably the four most important ones. A terminal is like a command line terminal, which I'm guessing, noting by the many nods, how many people here have ever used a command line terminal? Pretty good. It's more than I usually get in a pure math class. So let's start with a command line terminal. Notice it says a file. The way it works in SageMathCloud is for every terminal you create, there's an associated file. And that allows multiple people to open the terminal at once and see what the other people are typing. And you can sort of come back to it later. So you can give a name to your file. It defaults to the current time. I'll just call this my terminal. Click terminal. And now what it's doing is it's starting a little terminal server, and now we have a terminal, in which you can do things like type ls. You can type htop and see information about the computer that your project is running in. Okay? You can type vi if you like using vi and use it here. Actually, I'll make demo.py, make a little py, whoops, wrong extension name. So I type vi demo.py, print hello. And you can see it's colorful. You can also make the fonts bigger. And as I mentioned before, if you open the same document in another web browser, or in a moment you'll see that you can add other people as collaborators, then they'll see the same thing. So in a moment, as soon as there it is. So notice that we can both see this document, I don't know, u equals raw input, who are you? Everybody's first program. Okay, so notice that it's synchronized between the two. And it's kind of nice, like if you're programming somewhere, or even in a room with some other people, and you want to be able to see exactly what they're doing and kind of like switch back and forth, this is nice because you can do that. Right now, this project only has me on it. But if I search here, I can add other people. Okay? So does anybody else in this room have a SageMathCloud account? And a laptop. Open right now. Okay, who has a laptop at least? Obviously you two. Who has a laptop here that they can pull out? Okay, how about just somebody who's close? So as soon as you get your laptop, do you want to? Yeah. Okay, what's your name?
Sai.
How do you spell that?
S-A-A-D.
S-A-A-D. Okay, got it. And now I know how to pronounce it too. Create a SageMathCloud account and let me know when you've done so. Okay. And when he has, I'll be able to type Syed search, and his name will be one of these. And then I will find it. Hopefully he will, hopefully your last name isn't the same as somebody else, because there's no profiles yet here, so it can be difficult to distinguish people. If there's two people with the same name and you want to invite one of them, and you don't know which one to invite as a collaborator, you have to search by their email address, which they have to have entered. Otherwise, you won't be able to do that. So it's an important point. That will change as profiles get introduced. Okay, so in a few minutes, we'll add him as a collaborator, and then we'll see that he can edit things from his seat. But in any case, once you add somebody as a collaborator, they'll click on the project, they'll open it, and they'll see all of your files. They're actually now your group's files. And they can click on the terminal or the file that you're editing, like demo.py. They see the same thing. So over here we can edit the file graphically. We don't have to use VI or Emacs. That was just for fun at the beginning, or not. Okay, so here notice, for example, I can edit this file. This could be another person right here editing. So you can edit in one, it gets changed in the other one, etc. And there's a little cursor that you can see showing the other person editing. You can edit lots of different file types. This is a .py file. Certain other types of files will have a much more interesting editor. For example, Sage worksheets have an interactive editor where you type in code, like 2 plus 2, and you get output. I'll show you that in a minute. Kind of an obvious thing to try now is to run this program. So in the terminal, over here, I'm going to type Python demo.py and see what happens. Make this a little smaller. Who are you? William Stein. Hi. Okay, so now we've run our program. So this is exactly like what you might do if you were to log into some remote machine somewhere. In fact, we did just log in to a remote machine. The main difference is it's all integrated in your browser, plus it's collaborative in that you can add other people and they can do things at the same time. Also, there's not a lot of setup. You're not like trying to figure out how to log into the other computer and all that other nonsense. You just click a few times in your browser and you're good to go. Moreover, let's say we just close everything. Oops, our computer crashed and we just closed everything. So it's not like that terminal session is just gone. So if we just go back to SageMathCloud, so there's a list of all of our projects sorted by when they were last used. There's also this little bell which, in fact, tracks all the files either you or any of your collaborators edit in any of the projects that you're a collaborator on. And so, you know, we recently edited, well, the file demo.py. So you can see it right here. You could search for it if we want to see only the ACMS stuff. You can see it here. So we click, and we're back to our file. And even that terminal session, click there, and it should still be, oh, it's running. What's going on here? Well, it's there. My cursor seems funny, though. Ah, okay, now there's my cursor. But it still has the history, and I can type that. So that's a couple of things. Another important thing is that you can change your themes. So I think it's pretty important. So with the terminal, there's color schemes. So for example, maybe like a black background instead of a light background. So you can click Raven Dark. And if you go back here and close the terminal and reopen it, then you'll see it should. Oh, I forgot to save. There's a stupid thing when you change it, you also have to save the settings. Sorry about that. Okay, now, what the heck?
You have to save. I don't think you actually saved.
Oh, yeah, that's right. I didn't save it after, I saved it after not changing it, which is not going to work. I'm just going to refresh the whole thing. Okay, now it has a dark background. Oops. So you can change the background. I'm very curious. Oh, did you finish making your account? Okay, so let me try adding you as a collaborator. So what is your last name? ALA? Is that you? Okay, so one thing is when you create a new account, it caches the list of people for about 4 or 5 minutes for efficiency purposes. So it may be 4 or 5 minutes from when you made the account until it's available in the search. So we'll have to just try in a little bit. So that's what's going on there. All right, so we'll just wait and try it again in a couple of minutes, okay? Because I assume none of these are you. Okay, I'm just curious. Who prefers a dark background? Okay, who prefers a white background? Okay, so it's more, I don't know. Some people don't care, but then there's usually like 20 or 30% who desperately need a dark background. And then there's like 20 or 30% that desperately need a white background. So amazingly, these little details are really important. Otherwise, your head, I don't know, hurts. There's similar themes for editing files. So there's actually a lot more themes there. So in the terminal, there's a couple of themes. Then there's some more general themes here for colors. There's also a lot of settings that impact how the file editor works. So things like if you're editing HTML, whether or not it automatically matches brackets, and just lots of other things, whether it shows line numbers, whether it wraps lines or just lets them go off, etc. There's even one here, history log, which is on by default. when you're editing a file, it'll record all the changes as you make them, or any of your collaborators make them. So if we look at the file we were editing before, and by the way, often you want to find a file you recently were working on in a project where somebody else was. There's a log which shows each file that was opened in order, and you can search it. So if you're like, I remember I made a Python file, you can just search and it'll show only the Python files and when you made them. And you just click and you'll see that file. But I was just going to mention there's a little log button here as well. If you click on that, it gives you a version of the file with a little slider. And when you slide it, it undoes or redoes what you did in the graphical editor. It's not the entire history of the file because we partly edited it in VI on the command line. But the parts that we edited in the editor are here. By the way, a fun trick is that we can open this file on the command line and edit it, and it doesn't cause all kinds of, my cursor's gone again. Doesn't cause all kinds of trouble. So, let's see, this is a program. I'm not typing very well. Okay, I save it, and if I go over here, what it does is it periodically checks for changes from some other program, and if it sees any, it'll update the file that's here. So it's perfectly fine to have it opened and then change it via some other program, which if you're using Git or some other revision control system can be really important because you might have a whole bunch of files opened, and then you want to check out some different version or different branch, and you want them all to change in your editor. And it will properly do that. By the way, all of the development of SageMathCloud itself is done through SageMathCloud. So it can be used as a development environment. Okay. And even the history, by the way, so it automatically gets updated. I don't have to like reopen the history file. As I make changes, the history file even gets updated. By the way, let's see if I can add. See if it's, look, it's found you. Which one are you again? First one, okay, add. All right, great. Now look in your list of projects. So I'm gonna open the log so I can see when he opens this project. Look in your list of projects, you might have to refresh it, but you should see it. Yeah. You did see it, and now you open the project. And notice a little message appeared in this log which says that he opened this project. So now I know he did. Try opening some file. And then that will also appear here. Okay. So now he opened this file, and maybe type something. Maybe you could fix my stupid sad breakage right here by deleting that. Okay, thank you. All right, so that's the basic idea of the system. You have other people as collaborators who are on your project. As you can see, he's listed right here. If I'm tired of him, I can click the little X, and then he loses access to the project. He can't delete the owner, which is me, but he can add other collaborators. So if there's anybody else you want to add, all you have to do is just type something and add them, and they'll get added. So, yes?
So suppose I'm editing a file in Emacs, and I have a collaborator who's editing it in some other...
That would be bad.
Emacs. That would be bad, right?
Yes. If you're editing it through the graphical interface, you will each see each other's cursors. It'll be nicely synchronized. If you're editing in Emacs, what will happen is the person editing it graphically will see all your changes as you make them, but Emacs will start freaking out because Emacs will be like, hey, the file changed on disk whenever you try to save it. So that is definitely not supported. But speaking of the sort of thing you probably edit LATech documents, right? So now let's start looking at a couple of examples of more powerful, specific things you can do in here, like editing LATech documents. So if you click on the new button, it gives you this big dialog which lets you make various things and upload files. By the way, you can click here, and then you can just, like whatever you have on your computer, you can upload it. Like, I don't know, here's an image. I just uploaded that image right here. So there it is, etc. But you can also just click the little drop down and then choose to make a file very quickly. If you type a file name in right there first, it'll make it with that file name. I'm going to make a folder because LATech documents have bunches of files associated with them. So a LATech document. And then I'm going to click this and then folder. And that makes a folder called a LATech document. And now I'm inside of that folder. And then I can now click here, and then I want to make a new LATech document, so I'll just click LATech. And now I have a LATech document. It's just like what we were doing before, except in the left-hand side, you have your input document. Who here has ever used LATech? A couple of people. LATech is a program that lets you typeset beautiful-looking mathematical papers. It's kind of like Microsoft Word / HTML in that it produces documents like Word, but it's like HTML in that you write a source file which produces the nice output. It's used for like 99% of publishing in math and physics, so it's really, really big in those areas. So any professional-looking math book or paper was produced using LATech. So it's useful to know something about it. But it's extremely common that you could get an undergrad degree in math and applied math without ever having used LATech, which is a shame, but sorry that happens. In any case, here's an example of a LATech document. On the left, we have the input source, and on the right, the preview of the document. And you type stuff like, this is a sentence. I can't think of what to write. But the neat thing is you can typeset mathematics. So consider x cubed plus 17x plus 5 equals 0. And what you do is you put it in $signs. Notice it's nicely syntax highlighted. And whenever you save the document, on the other side it will, let me zoom this in a little, it will update the preview. So you can see there's a preview of what the final document will look like, and then there's the source document. You can click this little download button, and you'll get a PDF on your computer. So this is the PDF version of the document. The documents look extremely high quality. The mathematics layout, everything's just perfect. It's very, very good. Also, with this, what will happen is your thing on the right will get to be long. It'll be like 50 pages long. So what you can do is click over here, and it takes you to the corresponding point here. And conversely, if you're over here, you can click on forward, and it will take you to the corresponding point on the other side, which is useful. There's also lots of functionality for making slideshows, indexes, bibliographies, etc. And if you type LATech and then any of that stuff and search on Google, you'll either get a nice technical answer or some weird stuff involving latex. So you have to watch out. It's an unfortunate name for a typesetting system. But again, it's called LATech. Oh, I think the $signs are wrong, but that's good. Notice there's a little thing that says issues. If I click on that, it shows errors. And what happens is you get an error, and then you have to, the errors are often extremely difficult and cryptic to understand, unfortunately. But if you click here, it takes you to the point where the error occurred, and then you can fix it, which is that shouldn't have been, it's not math, so it shouldn't be there. It's just like that's the way that the word LATech is supposed to be written. Okay, so that's LATech, and if we look back here at the file system, you'll see that there are several files that are kind of auxiliary files that are left laying around as a result of using LATech. The original file that I was showing you on the left is the file that ends in .tex, and it's the only file you really need. But there's others, like the PDF file. Okay, so it's kind of like how you make websites. You write HTML and you get a website. Here you write .tex files and you get a PDF. Okay, next I will show you a Sage worksheet. So click Sage worksheet. Make that a little smaller. All right. It's kind of small. So right now it says loading. The very first time that you create a Sage worksheet, it might take like 4 or 5 seconds to start up a Sage server running in your project. After that, additional worksheets start instantly because they just fork off from the master server. In any case, this looks like a document just like the others, but as you're about to see, it's extremely powerful. Watch this. I typed 2 + 2, and then I hit Shift-Enter, and it outputs 4. But you can do a lot more than that. You can write arbitrary little Python programs, and you can interactively change them and hit Shift-Enter or click the Run button to see the output. But you can also do everything that, for example, the software Sage, the math software program supports, which is drawing sophisticated plots, computing symbolic integrals, etc. Also, there's an enormous number of Python libraries that are pre-installed in here. And you can also use other systems like R from here. So for example, just to give you a sense of the power of this, well, it's pretty unimpressive, but I've just computed, well, I'm now computing 2 plus 2 using R. Okay, that probably didn't even convince you that I was using R, but I'll compute the standard deviation of a bunch of numbers that I'm randomly making up using R. Okay, and there's one R session that's running. So to convince you of that, up here, I'll make this list of values using R, and then down here, so evaluate that again, and then here I compute that. So it's an R session. It's probably hard to tell, but syntax highlighting is correct in here. I can make this bigger, clicking A, etc. There's even a little bar at the top that gives things, and if you type %R at the front of a cell, then the bar changes to give you R examples and information. So I don't know what linear model does, but here we are. So this inserts a snippet of code, and then when you evaluate it, you see the results computed using R. Right? And R is just one of many things that are available.
When you want to get out, you get out of R in your backend.
Yep. You don't even get out. It's just you
end the R session.
You don't have to end it. It's just like in this cell that started with %R, this is evaluated using R. Everything else is evaluated using Sage. Or you could do something else, and it'll be evaluated using that.
So then if I start octaves, for example.
Yep. So let's do octave. And by the way, there's a list of modes here, at least common modes, which apparently I didn't include octave, but it's there. There's a much longer list that's actually supported. I'll make a random matrix using octave. Which I don't know if it's taking. Hopefully it works. Looks a little. It could just take a little while to start up octave. Surprised this isn't working. Yep, here it is. Okay, I'm very impatient, as you might see. So this is an octave session. So by the way, behind the scenes, well, in fact, it's not even that hidden. If you type in your terminal, let's get out of this. We just type top, or top-u, who am I? Okay, so what that does is it shows all the processes running as you. There should be a nice graphical display of this, but I haven't written that yet. But in any case, notice that there's a couple of Python programs running. There's a single R program sitting there running. There's an octave program running, and so on. Okay, so that's exactly what's running in this project. And the user it's running as has this name, or user ID actually. So that's what's happening behind the scenes. In our Sage session, you can just run little bits of code using your R session, using your octave session, etc., interleave them however you want. So Sage is sitting here. It's this Python program. It opens up an octave session. It opens up an R session, sends commands, gets results, and there you go. Okay. So that's just one thing you can do with this. I mean, you might never use any of those other modes. It just depends. By the way, graphics should work very well if you're using R. Just use the normal graphics commands, and they'll appear as nice SVGs. Does anyone here know R? Okay, how would I plot my data, this V I made? How can I make some graphic using R? So, plot? Well, that sounds like a good try. Either it's right or it'll get an error. Hey, it worked, you're right. Okay, so that's a nice SVG image. You can, click on and right-click on it and save it or whatever. So you can have nice images embedded and, obviously much more sophisticated stuff. Okay, so there you are. And this worksheet's starting to get long, as you can tell. Often when you're using a worksheet, you want to look at multiple points at once in the worksheet. And there are two ways you can do that. One is you could just open another browser at the same time. If you have two laptops, then you could open one on each laptop, and then you have two screens, and then, or you can just open another tab and just look at the same document in multiple browsers. And that works fine because it's synchronized. Alternatively, you can click on this button right here, which looks like a screen with a line through it, and that will split the display. So you can see one part of the document while also looking at another. So, so right here we have our plot that we made. And then here we have the line where we made the data in the first place. Okay? And you can independently change the font size. Like if you select the bottom one, you can make the font really small, whereas the top one, you can make it really big. You can also click this little arrow to full screen one particular document you're working with, which is nice. If you click this button one more time, instead of splitting horizontally, it splits the screen vertically. So you can see something here, but at the same time, you can get this kind of high-level overview of everything in your document. Okay, and you can, of course, drag this bar if you want to make that smaller. So you have like multiple views, and they're updated. Like as you type over here, I mean, I can't really see what I'm doing there, but it does update it. They're linked together at the same time. Okay, let's see. You can also, has anyone here ever heard of Markdown? Raise your hand if you've heard of Markdown. Not very many people. That's a bummer. But raise your hand if you've heard of HTML. Okay, that's everyone. You can type %HTML and then just take pretty much any HTML that was created in any way and just have it appear in the output. So H2, this is, let's see. So I had to actually think hard to remember the color stuff, but notice when I went %HTML, it actually made an editor bar at the top. I know this is small, so maybe I should make it a little bigger. And so like if I want to write some HTML and I'm like, oh, I need to put an image in or a table or a link, you just click here, and then you can fill in a little thing. And then when you hit create link, it will create the corresponding link, as you can see. So when you hit Shift Enter, it evaluates that, and then it displays the HTML that you just entered. The input disappears by default with HTML, and you have to double-click on the output to see the input again. So people don't know Markdown so much, but what you do is you write stuff that kind of looks like what you'd write in an email message. It's simpler, but what it'll do is turn it into something that looks nice. So it's a format for doing that. Okay, so that's the way you can put comments in your document. You can also, I promised you drawing plots using Sage itself. So there's a bunch of examples right here of various plots. So let's try just plotting a function. So this is just a simple example. I'm going to hide the thing on the right since we don't need it. So this is an example of plotting x times sine of x from -2 to 10. This is an SVG image, but if you want an image in a different format, you can create the plot by assigning it to a variable and then do, well, if I do that, it'll show it again, but I can also then, I can do like g.save a.pdf and it will save that file locally. Yes?
Are there directions on the website how to plot that, how to type it in?
Sure. So let me undo a little bit. So let's say, so there's a few examples which you can just get by clicking here, but obviously this isn't going to tell you everything about plotting. So first, you can Google for Sage space plot, and you'll almost certainly land on the reference manual, which will have thousands of pages about how to do stuff in Sage. So let's just try that, Sage plot. And indeed, this is the Sage reference manual, and this is the chapter on 2D plotting. And there's lots and lots and lots of functions in here. Okay, and you can use any of them. You just use them. So I don't know. Let's try. Anybody want to? Okay, matrix plot. So click there, tells you all about it, has examples. One thing that we pushed really hard for in Sage, the math software, is that there's lots of examples, because I think personally that the easiest way to get going with using this, instead of trying to read a technical specification and then deduce how to use it, is to copy and paste an example and change it. Does anyone here agree with me? Hell yeah. I mean, that's exactly what you want. So in fact, I think right now 96% of the functions in Sage, and there are many, many functions, have examples illustrating their usage. We want to get that to 100%. It's very close. But in any case, we should be able to take any of these examples. This one looks fun. It's just random. And just copy it and then paste it in to our document. And there we are. So there's a matrix plot. Okay. There's also, so that's Sage's 2D plotting. There is also plotting functionality that comes with a library called matplotlib, which is very MATLAB-like, which as you're applied math people, I assume you probably have used MATLAB a lot. So it's called matplotlib. And I'll write that down. You can just use all of this stuff, matplotlib, in Sage worksheets as well. So this is a gallery, so you can basically just browse through this for something that looks like what you want to plot. I don't know, let's take that one. And then there's some source code. Oops, it downloaded it. But here it is. So I'm just going to copy it and paste it and cross my fingers. And evaluate it. So I just evaluated that code, and then it printed out a bunch of stuff, and there's the plot, which I copied. And then you could change the code and get what you really want. Okay? Yes?
So let's say I want that plot to use something, and so I can easily just save that onto my computer and done.
Yep. So if you want this specific image, you could right-click. It's just an image in here.
Okay.
Let's see. Open image in new tab. It's an SVG image by default. So, and you could also screenshot it or something, but you can probably drag and drop this image into whatever program you use. Okay. All right. So let me show you a little more. So there's some nice 3D plotting. There's a fun one. So this is a 3D implicit plot of the function. So P is 2 minus the quantity cos x plus gy, blah, blah, blah. So it's plotting where that sum of cosines is equal to 0. And then this is the plot that's produced. So you can zoom in. Notice it has transparency. You can move it around with the mouse, etc. And it spins because I set spin equals to 1. The second I move the mouse out of the display, it turns it into an image, which makes it so that if you put 50 of these in one worksheet, it'll actually work because it's only spinning around one at once, and the other ones are static. I just have to tell you because you have no idea how much work it was to get this to work properly. Behind the scenes, this uses a library called 3.js, which is a JavaScript library built on WebGL. Uses accelerated 3D graphics to draw images. Okay, and like with 2D graphics, if you look in the Sage reference manual, and you kind of go up a little from 2D plotting, so I guess, yeah, Sage doc. Well, that went a little too far. Maybe just in modules. Okay, nope. Index. I want the table of contents. Maybe this. Ah, here it is. Okay, so 3D graphics. Click there, and you see many sections. There's a lot more you can do involving 3D graphics. Okay. So I don't know, just one other example. Go to plots. Okay, how about a 3D random walk? That might be fun. And I'll explain the code here. So what this does is it makes a list with the 3 tuple 0, 0, 0 in it. And then maybe I'll talk while it draws it in case it takes a long time. Oh, that wasn't a long time. So it takes 1,000 steps randomly, and you get a 3D random walk. So that's what this is a picture of. And just to emphasize the collaborative nature of this, can you change something? Maybe change the length of the random walk or the color. Change the color. So in order for you to find the worksheet I'm working on, if you look at log, if I click the log thing right here in your project, then you'll see lots of stuff. That looks like you found it already. And you should be able to find line 98 and change that red to something else. Is it working or? Yep. If you're trying to go to a particular line, there's a lightning bolt which takes you to a given line. Probably a dumb design, but in case there it is. And then if you evaluate that, you just hit Shift Enter when you're with your cursor in that cell, and it will rerun the code. And not only did you see it, I see the modified code, which is nice. So it's very, very synchronized. By the way, this log thing, so the history of what was edited in the file works even for worksheets. So if I click on log, I get a version of this with a slider, and I can go down here, and I'm like, oh no, who messed up my 3D plot? So notice it's messed up here. So I can drag the slider and it'll undo sort of all this stuff that happened. And it even shows you the output as it undoes it. So it goes back to red, etc. By the way, the way this works is there's just a hidden file, .filename, .sagehistory, that has a list of all of the changes. And you can save the history of the file as well. It's not like stored in some database somewhere or anything like that. It's just an extra file sitting next to your normal file that records the changes as you're typing every few keystrokes. And that was mostly implemented by John. John Lee. Sorry, he was a freshman undergrad here last year. So he wrote the history stuff over the summer. He's a CS major at UW. Okay, so there's that. Here's our worksheet again. I'm going to make the random walk longer since clearly 1,000 wasn't going to kill us. And I'm going to make it thinner. Anyways, it's just nice how you can play around by just changing things and seeing the output. And yeah, you can also, like, if you do something, you can copy and paste it. Let's say you just want the 3D plot stuff. So, I mean, this shouldn't be amazing to you at all, but you can copy and then make a new worksheet. I'll call it 3D. And then you can paste it, and it actually works. So with the images there, you could even copy and paste it into another project or whatever. Because the images they're really just UIDs that reference something in a database. So you can copy and paste them all over the place very efficiently. And also when I did the copy paste, it spanned multiple cells and so on. So that's nice. Okay, so yes.
So you could paste one of these things into a LATech document?
I'm afraid not.
Okay, so
couldn't quite do that.
Okay.
Yeah, that would be
Not
nice.
too far out.
Yeah, not yet. Although you're giving me ideas because there's no reason that wouldn't work. It just doesn't work yet.
That would be kind of
Maybe in a few months. I don't see why it wouldn't work. It knows a lot. Okay, so it would be possible, but that doesn't exist yet. Okay, so let me show you a little bit more. So in addition to Sage worksheets, there's the terminal I showed you. There's Jupyter notebooks. So I don't know if has anyone heard of IPython? At least 3 or 4 people. And then there was the IPython notebook. They renamed IPython Jupyter. And I just created a new Jupyter notebook. It takes a little while to open the first time because it's starting up a server. And then after that, it's quick to open. That's the case of a lot of things. So here is a Jupyter notebook. This is similar in many ways to Sage worksheets, but there's a lot of different design decisions. And these are used by a lot more people. But the basic idea is very similar. I'm going to zoom in a little so you can see. So you type in some code, hit Shift Enter, get some output. You write little programs like for I in range 10, print I, etc. And one of the differences, basically, it's an approach to solving the same problem, namely interactively working with code. But in a sense, every design decision is different for Jupyter than Sage worksheets. So either one or the other might be perfect for your personal use, depending on what you're doing. So they're very complementary. So one neat thing you could do with Jupyter worksheets is there's different kernels. So for example, Sage worksheets currently only support Python 2, whereas with Jupyter, you can switch to a Python 3 kernel, and then all of your code gets evaluated using Python 3, which if you don't know Python, that should seem ridiculous to even say that. Why doesn't everybody use Python 3? But the leader of the Python project decided to make a new version called Python 3 like a million years ago, and not everybody switched quickly. And so now probably more people still use the old version of Python than the new version. And so there's this weird, they're incompatible with each other. It's kind of ugly. You can switch to Julia mode, and then the whole worksheet is a Julia worksheet. Or you can switch to R mode, and the entire worksheet is an R worksheet. So there's no like %R that you have to do or anything like that. Though they do support a % type thing. And you can search for information about Jupyter notebooks on the Jupyter website. And then similarly, there's some nice things. There's a publish button. So if you click this, it'll give you what it does is it makes an HTML version of the worksheet that you're looking at, or sorry, the notebook. There's the link. And it also makes it public so that you can then share that with other people without having to make them collaborators on the project. You can, in fact, make any directory or files public. There's just...
So when you change to an R worksheet, for
yes.
example, it changes the
Let's do it.
syntax?
Yep, it's R. Like, it says, it just completely quits. There's no more Python anymore. It's entirely 100% an R
And any
notebook.
syntax changes that automatically figured out?
Nope. This stuff would be a syntax. If I try to evaluate this, I'll get a syntax error.
Oh, okay.
Yeah, and then I can do like C 1, 2, 3, 4, 5. That's valid R. So, and there's a lot of kernels. These are the ones that are supported in SageMathCloud, but there are, I mean, a lot of people use IPython outside of SageMathCloud. And it also even has like making, let's see, different types of cells, like a Markdown cell. Where you can kind of mix LATech and it typesets it nicely. And then you click on it to edit it, or double click to edit it. So you can describe what you're doing and then do it. And there's an enormous number of Jupyter worksheets just out there already available for various books, illustrating things, etc. It's an extremely popular format, and you can just load them into here and use them. One nice thing is the synchronization stuff that I was showing you before also works with Jupyter notebooks, and that was a huge amount of work. And so like if I edit stuff right here, it will change in the other one. One issue though, so it's not quite as good in that if one person starts editing, the other person's cursor will lose focus sometimes if you're editing at the exact same time. So that will probably get fixed soon, but that's the one issue. So like literally simultaneous editing is a little bit annoying, but at least you can have two people that are working on the same notebook without going crazy, having to constantly synchronize each other's work. One thing I just want to quickly go back to, so remember we have this worksheet, there's no little publish button here, but there's an I button. If I click on that, then I can say share publicly. So if I click on this, then it switches the state of that worksheet. And now anyone who, you just take the link in the URL, and I'll open a private browsing session so it doesn't know anything about my login. If you share this link with anybody, then when they open the page, they'll see the input, the output, and they'll get an option to copy this worksheet to their own project, which if we click on it, because I'm not logged in this browser window, it'll suggest that I create a free account so I can start editing this code. Yes?
But they can't edit this?
No, this is just a static file. That, in fact, it's read-only. Like if you try to type, that's what the read-only says right there.
Oh, I didn't see that.
Yeah. But it's a really easy way to share a file, or in fact, a whole directory of files, or whatever, with other people. For directories, if you're in the file browser, Off to the left of each file, there's a little I for information about it. So if I click I next to LATech document, and then click Share Publicly, now this whole directory is public. And then I can just click on it. And again, if somebody were to view this link, then they'll see that directory. I think that was not in the private session, sorry. That's still not in the private session. Ah, there it is. So they can't do very much with it, but at least they could copy the files out and start working with them, and so on. They could open the PDF file, etc. Okay, so that is most everything. There's some other things like backups. Actually, that's an important thing to point out. SageMathCloud will snapshot the complete state of all the files in your project roughly every 10 minutes when you're actively using the project. And so if you mess things up for some reason, then you can click and see what things were like 24 minutes ago. And there they were. And that allows you to recover from adding, so 35 minutes ago, this is what it looked like. And so you just have this like way to go back in time. It's just sort of integrated in with it. So if you add somebody, so I add you as a collaborator, but then it turns out that you don't know what you're doing and you accidentally delete all my files or mess everything up, it's not a big problem because there are these snapshots. So that's another thing to point out.
When you go to a snapshot, how do you?
You just open. You can just open the file and copy paste, or you can click on I and then say copy, and it just if you click copy file, then copy it back over the other version. So basically I and then copy.
So right now you have all these different sessions. You have an R session running.
Oh, yeah. Yep.
Okay, so what happens when you then just turn off your laptop?
So what happens if I turn off my laptop is that, I'm just going to do the quota, there's a 1 hour timeout.
Oh, okay.
So if nobody does anything in this project for 1 hour, it kills all the processes that are running, and that's it. That can change, like since I'm the administrator, I can make it a 5 hour timeout. So now, if nobody changes anything for 5 hours, it'll kill everything. So, and there's other quotas here, like memory, disk space, etc. Okay, there are other file types that you can edit and other things you can do, but I think you get the basic point now. Okay, so any questions? Any more questions? I'm done with my whole talk. I don't know what the time is. So, okay.
We have plenty of time.
Okay, great. Yep.
It's all free.
Yeah. So.
I thought I saw something of it's billing or something.
Yeah, there is in fact a billing tab, which says billing is not implemented.
Oh.
So there is and will always be a free. You can make free projects, but there's quotas on those projects, and if you want to raise the quotas, that's when in the future you'll have to pay something. And in the very near, most of the, or a big chunk of this runs on Google Compute Engine, which costs money, and the amount you pay will be just related to how much it costs. So.
In particular, yeah, the Octave is kind of like that.
Oh.
So instead of buying.
Oh yeah. A key point is that all of the software that is running, 100% of the software that I've been running for you is free and open source. There's absolutely nothing that I've showed you that isn't free and open source, including SageMathCloud itself. Like the complete source code of this web application is also free and open source. So, but yeah, Sage is completely free and open source. You can download Sage, for example, and run it on your own laptop. If you go to the website, there's a download link. So you have binaries and source code. Octave's free, R is free, etc. And yeah, right now you could just start making projects, and it's currently it's completely 100% free. But what happens is if, for example, you're here and you're like, geez, I really wish that my project had certain extra features. When you click on Upgrade Project, it says billing's not implemented, so just email this address if you need to raise something, and we'll just raise it. And then it suggests that you donate. Not very many people donate, as it turns out. We've had this link up for about 4 or 5 months, and there's a link here. There's a whole bunch of, this link is all over the place. and it results in about $200 a month in donations, which is really sad because it costs about $2,000 a month to run the site. So donations do not work, sadly, at least with the target audience. How many people in this room have donated to something, donated actual cash in the last, I don't know, this year?
Oh wait,
Curious.
this count.
During 2015. You have. Okay. Anyone else? You have. Good. Okay. Surprising number of people. I'm very happy for you. But I don't think donations are the best possible business model for supporting something like this when the target audience is undergraduates. No offense. But by the way, just to get a sense of usage, so right now there's 583 people who are signed in using the site. And in the last 24 hours, almost 3,000 different projects were modified. And you can see information, historical information here. Typically, so this shows, for example, the number of projects modified in the last 24 hours. So it's increasing quite a bit every single day. So usage is going up a lot. And this is a plot that's kind of messed up, but it shows the number of, it shows project creation during a given day. So on that day, somebody created a bunch of projects, and then projects were slowly created. And also people created accounts. And just usage-wise, I looked yesterday, and the biggest country using it yesterday was the United States, and then the biggest one under that was Croatia, with over 300 users, which is surprising. But usually, the second biggest overall is usually Canada after the US, and then a bunch of countries in Europe. And then Hilo, Hawaii is a huge, huge user. These are just plots about the number of users over time. So number of accounts and projects. There's about 150,000 projects total that people have created and about 95,000 accounts. Okay, so there's that. Any other questions about this besides, is it free?
Okay, well, let's thank our speaker.
Okay, thanks.